The following is a presentation of NoVA Hackers at ShmooCon Epilogue 2014, hosted by Mach37, brought to you by Compute Cycle.
So my name is Randall, and a big thanks to Rob and everyone for organizing this. ShmooCon Epilogue is a wonderful event. I'm so dedicated to the NoVA Hackers group, I regularly fly in from Ohio for the meetings. If you're not regularly attending, you're missing out. It is one of the premier groups, I'm convinced, not just in the country, but on the planet. It's a phenomenal group of individuals. Today we're going to be talking about Bro, which is something that you know that I'm very excited about. I've been talking about it for a few years. And I thought we'd start out by just doing a quick overview. Bro has a lot of innovative features, and one of the most exciting ones we introduced is one we're still trying to figure out. It's called the Files Framework, and it's a general abstraction that allows you just to start thinking of your network as a series of files. So we're going to start today, and we'll do a quick 2-minute overview of what is Bro for those of you that haven't heard of it before. We'll talk about the design of the Files Framework, and then we'll think about files one at a time and how the Files Framework allows you to maybe automate some of the static and dynamic inspection that you're doing in your environment now. Then we'll do some demos, and then we'll take a step back and look at the macro view to think about what are the most popular files on the network? What does that mean for your network? What are the least popular files? Thinking about files in different ways than I think you're used to expecting. And then we'll close up with a final demo where we take what I think is a pretty interesting approach to dynamic device management using this new capability on your network. And then I think we can end with questions or more Bro jokes, your choice. So this is me. My name is Liam Randall. I'm the managing partner at Broala LLC. We're the professional services company that is building products out of Bro, the open source National Science Foundation funded platform. If you haven't heard of Bro, we've been around for quite some time. Just recently, the NSF renewed our funding with another $4 million, which is a huge vote of confidence for our team. We're primarily divided between UC Berkeley at the International Computer Science Institute and the National Center for Supercomputing Applications in Champaign-Urbana, Illinois. The team includes some of the, in my opinion, some of the brightest people on the planet. Including our founder, Vern Paxson. He's been publishing cutting-edge research papers for a long time for guys like Robin. Robin Summers, our PI that works on the programming language itself. Robin builds a cool programming language for guys like Seth, who build all these cool frameworks for guys like me, who build neat tools and applications for networks for guys like you. So, and then you guys build stuff out of that for your customers and your clients. So that's sort of the circle of life in this sort of a research-heavy world. I speak pretty regularly. I'll be at MOG next month for anybody who's associated with ISPs or telcos teaching Bro classes again. I think that's the San Francisco meeting. I think I'm going to be speaking and teaching classes at 44Con in London, and I'm speaking in Florida somewhere in May. And I have a number of other engagements. I try to put them on my website, but I generally, if people ask, I'm always happy to talk about Bro. So let's get started and just do a quick Bro review, right? So what the heck is Bro? So for a long time, if you reached out to Bro years ago, you may have just thought of Bro as an IDS. And for a long time, it was simply designed with security purposes in mind. But a few years ago, we started to realize that this platform had capabilities that were way beyond intrusion detection. So when you think about Bro, think about it as this big set of software that you install on a Linux or FreeBSD box, and it has all these protocol analyzers and these daemons and everything to get it up and running, and the ability to divide the traffic scalably by 5 tuple flows. As a data point, we're running Bro at 80 gigabits per second at a major university, and I'm confident we're going to hit 100 this year. We turned up Bro at 40 gigabits per second in 2011, 10 gig in 2007, so it's highly scalable. So at its core, Bro is a programming language. So just like Python is a programming language, you can write all kinds of things out of Bro. Syntactically, it's very similar to Python, except it's event-driven. If you've ever done event-based programming, what happens in Bro is Bro sort of gives you events when things happen on the network. Whenever you do a DNS request, the DNS request event fires, and you can hook it and do whatever you want. And then ultimately what you do is you run these applications on top of the platform. So one of the major applications driving the adoption of Bro right now is Bro IDS, which is sort of what we were designing Bro from the beginning. But we have started releasing scripts around DLP, monitoring, file analysis, compliance, and a huge variety of other use cases. On our internal tracker, we have over 200 distinct applications that we would like to build and open source out of Bro. Bro is completely BSD licensed, for those of you that haven't used it before. It's truly free for all use cases. So mentally, this is what you think about Bro as. You spin up the platform, and then you run all these apps on it, and they do all the things, right? They hook into the traffic. So when you're using Bro, the sort of advantage that this files framework is going to give us is that we take this passive feed of both the TX and the RX channel on the network. So we see both sides of the flow. And what we're doing is because we're speaking the standard protocols that tie the internet together, it means that we can tap all the things. If you think about all the devices in your pocket or in your house or on your corporate networks, Rob had mentioned IP cameras earlier, which I have a soft spot in my heart for. It's actually my presentation again today. You get this ability to interact with everything. We're not agent-based. It's not just the devices that are running Windows XP or the devices that are under your control. If it's on your network, you have visibility and insight into these things. So the first thing Bro's going to do is we're going to write all these detailed protocol logs, right? So this would be like DNS and HTTP, you unwrap all the tunnels. So files.log is now this new, not really a protocol log, but we think of protocols as bidirectional streams, and a file is just a unidirectional stream. So maybe I should stop saying that we write protocol logs and say we write stream logs, right? Maybe that's sort of a different way to think about your network, but it accurately reflects that Unix mindset that everything's a stream and you can just pipe it all together, right, with building blocks. So Bro does that, and you can then ultimately pivot around these things. You could say, well, if I see 10 files accessed on this share, or if I see an executable downloaded from a particular country code or ASN, I could write an alert. So the second type of log we do would be like an alert log. So when I'm doing demonstrations later today, we're going to observe things in this unidirectional stream log, the files.log, and then we're going to pivot and do things like alert around them or react or interact with the devices that are doing that. The final thing we can do, and this is where the files framework really gets sexy, is actions. Bro is simply a programming language. So pivoting out to various applications is something we're going to demo today. So things like static and dynamic analysis, those are the things that we're working on right now, adding and building into Bro. The things that right now you do manually, or you pull out of a network stream, you pull it out of a PCAP and then analyze it, and then you take this data point over here. We want to unify that. And there's this very powerful idea that's associated when you do that. And that is that your analysis is now attached to a particular flow, to an endpoint, a source destination, to a point in time. If you understand how the internet works, IP addresses can be announced from different locations at different points in time. One of the demonstrations I'll show you is pivoting to an ASN. So you could start to say, how many PDFs did we download per ASN or per country code? I don't know that there's been a lot of thought put into those kind of questions because there's not been an easy way to ask those scalably all the time on your network. So this is the area that I think I'm most excited about. So talking about extracted files, I gave a talk last year at ShmooCon about this, and I called this the Bromus story, which would involve shooting my eye out with a BB gun. But this should actually be the Bromus Carol. So when you think about all these files now that we have access to that we're pulling right out of all the streams all the time, you could think about the past signature analysis. In our demos later, we're going to pivot out to known databases of things. Is it on the National Software Reference Library? Is it in these big databases of known evil things? Active analysis. We're going to grab a file off the wire, we're going to run it through a tool, and we're going to pull that back into Bro, and we're going to have access to that analysis now in Bro with the network streams in real time. Long-term analysis, just saving files out and saying, hey, if an executable comes into my network, maybe I should have a copy of it. I'm on the security team, I'm responsible for supporting it. If a PDF comes in, save them over here. or predicative analysis. I don't think, if we have time today, I'll demonstrate it, but a great alert that I like to fire off the files.log is when anyone downloads malware bytes, because there's a wonderful derivative piece of intelligence that is typically lost on most networks. And that's simply that there's a user at their desk who's saying, I have a problem and I'm smart enough to fix it myself. So this point of view is very, very powerful. I'm not going to take that, sorry. So let's talk about this files framework. Pardon me. So the files framework, let's talk about where we were with files. So in old Bro, we introduced this ability to extract files based on protocol. And it was a per protocol setting. And I'm going to do an example here in a second where we talk about the base case. But we had this realization that we were replicating work here, that you may not even really care what protocol a file came from. So we started to take another step back, and instead of saying you can enable file extraction by protocol type, to just say you have this new event that fires in Bro called new file. So there was a lot of inspiration for this over the years. So there's a gentleman by the name of Charles Schmutz. That is the logo for Ruminate IDS. And his big idea was file reassembly and passing files to other tools and parsers in real time as part of his IDS system. It's an interesting project. If you want to take a look at it, I don't think that it's actively maintained. It's been a few years that this has been sort of percolating in our minds here. So the general realization is simply this, that a file is just a unidirectional byte stream. Right? And it's the same thing that Bro's already doing. Years ago, I mentioned Bro, the Bro network programming language. It was subtle. I don't know that many people caught it, but we deliberately dropped it and started just calling it the Bro programming language. Because to us, when we're attaching these file analyzers to traffic on the wire, right? You think about it, it's like layered traffic. You have all these, byte offsets and parsers. There's no difference to us for a protocol parser than there is for a file parser. Even when you start to get into analysis, you track state on a protocol like HTTP, like keeping track of a conversation. You can track state within a file. And when I demonstrate a file analyzer later, I think that analogy will start to really come together in your minds. So these things also work incrementally, which is one of the most important concepts in Bro. So our new files framework is now source agnostic. Files can come out of files. Files can come out of any unencrypted file protocol. And they feed right into our input framework, which means now that you can simply point Bro at a file share and say, hey, Bro, read all that. I think that's kind of neat when you start to realize this kind of a Unixy stream point of view here. And it's moving us very quickly out of simply the network space. And when you think about when we're building in things like PE header analyzers into Bro, pointing this now at your directory, and Bro already will hash all the files, hash all the things for you. We'll look at the specific capabilities in just a moment. That is a powerful thing, that last line there, the input framework. So implementation. We want to keep the data out of script land. Actually, the slide is wrong. Reassembly has now been added to Bro. There was a very silent commit about 3 weeks ago, and I was extremely blown away. When we sat down and spec'd the development effort, we tagged it at 60 days. And the developer that handled it, Seth Hall, who was going to co-give this with me at ShmooCon, had we been called up, we were the backup speakers, actually completed it in like 2 days. And I was like, Seth, what happened? And he's like, well, the internal API for the TCP stream reassembly stuff that we do in Bro already was written correctly just to take chunk data. So we're able to use the same interface internally for file data. That says a whole heck of a lot about the guys that started this project almost 2 decades ago. That code that we actually used was written in the 90s. That's how scalable it really is. So that's a neat little concept. So let's talk about a base case here. I'm going to make a comparison for those that will make sense to people that are using Bro now, which I don't think is too many of you. So in Bro now, let's say you're tapping an HTTP conversation, right? You're just monitoring the traffic here. When we fire our event for HTTP, we do not specify any of these things in this event. We just throw this event up in the air and it says, hey, there is an HTTP event. It's the base case of that protocol. Here's what the event actually looks like. I don't know what's in that box. Oh, it's a wrench. Right? This is the event. It fires up and it just goes, pew! All right? So what's not here? All of those things that I just showed you. And nowhere in this event does this say, was this on IPv4 or IPv6? It doesn't say what port it was on. It was dynamically detected, so we know that this traffic is matching this protocol analyzer, right? So you're reducing down to this base case, because if you care about those things, then care about them in your first line of code. You know, you pivot and say, is the content type on this traction, on this communication, is this the Cyrillic character set? That's what Win 1251 is. So we're reducing down to that base case of traffic. And if you care about those other things, then you care about it when you're developing. And I like the symmetry between the files framework, because now we do the same thing with files. It doesn't matter what protocol it's coming in on, under development on that last one. You just get this new event. You just get this, another wrench, hey, look at that. You just get this new event that says, hey, there's a new file. And if you care that, if you only want to look at files that come in over HTTP, you then care about it in your first line. When this event fires, you say, if source was SMTP, right? And MIME type PDF, then attach the extract, then attach that file analyzer. So this particular line of code, what you're looking at, this is a valid Bro program. This will extract all the files from all the streams. Right? You can just copy that into a file, include it, or run it with Bro against the PCAP, and it'll extract everything that it has the ability to extract. So everything we have a protocol analyzer for. So this is a very high level kind of thing. And so if you only wanted to extract DOS execs, that is a full complete Brogram right there. That's not a real word, I don't like that. So this is a full complete application, a Bro script that'll work, right? It's this base case. And if you only wanted to extract DOS execs that we're seeing on HTTP, there would literally be a first line in front of it that was, you know, if source HTTP, or HTTP on port 80, right? So you'd have two if statements there. You'd have one if statement, just two more ands. So we have this real symmetry here. So when we're writing these big logs, I showed you guys some screenshots earlier. If you haven't used Bro, Bro is very sexy and Unixy, right? When we get to demos, we'll actually look at logs here. But let's follow this now from the top to the bottom. So this is the bottom of the cake here. This is the connection log, okay? So the key thing here is that we use these things. If you're any SQL programmers in the house, all right, drop tables. So bad. So, you know, think of this as like your key, right? Your key value for pivoting between tables. Okay, so here we have like a UID, and we have the symmetry even between the logs. As we design these logs, there's a lot of art that goes into this. This is the HTTP log. You can see that it looks very similar, right? Here's that UID that ties right up the stack here. And now we're introducing this new thing down here. See this thing in orange? This would be the any responder file UIDs or originator file UIDs. So files that came from either direction. This same sexy log that would then pivot right to the files.log. And you can see here now that you have the same key that ties all the way back. And you can now tie this file to a flow. And if there's an analysis tied to this file, you now have this chain of events that gives you the ability to say count malicious PDFs by ASN, right? Those are, I will do a demonstration later where I think that there is some use in those metrics. They're not bulletproof, but they're certainly interesting. So as we start looking at these examples, you'll see that in the files.log, you can turn on a number of analyzers here. So for this particular file, we only turned on the SHA-1, the MD5, and the PE header analyzer. So Bro can reprogram itself while you're using it. You can use, if statements or ask Bro questions to say, hey, if we meet certain conditions, then attach this particular analyzer. I refer to this process as candidate selection, but you guys can call it whatever you want. There's no official name for it. The idea though is that you can be very dynamic. You don't have to just say extract all the HTTPs. You could say, extract all the, or let's say extract all the PDFs in email. You could say extract all the PDFs that come into the network, right? You can reprogram and interact with these things on the fly. So we have all these forensic capabilities with this. So as we're firing these analyzers and doing these attachments, this is a log that we're going to look at in just a minute here. And this is a notice.log. So what we're doing here is there's an analysis that's been run here. In this case, the analysis was simply a pivot to an external data source. And there was a hit. And this was a known bad thing in the Team Comrie malware hash registry. And it also includes a log. This is a direct extraction. If you download Bro 2.2 and just run it with default settings, this is running by default. So if you're using Bro already, these are the logs that you're looking at. I mean, this is a really powerful capability. And we're working on adding additional integrations as we go. So by putting these URLs in here, Bro's this programming language, we can pull in data from a variety of places. So now when my analysts are running these large networks on the baseline of thing, I pull up my notice.log and suddenly I have this kind of neat view about thinking about, well, where do files come into the network? Where do they leave the network? What are the key servers and what types of files are they serving? So if there's one thing that you pay attention to today, please make it this animation that I spend 30 minutes on, okay? Please, okay, so this is Bro. So we have a file. Now, I don't care what protocol it is. Pick a protocol that it's coming down the wire on. And this is you. Let's say it's over HTTP because the laptop says www. So we have our network here and a tap. So Bro's seeing the TX and the RX. This is a very powerful concept in computer science, and it's very critical to actually understand what's going on here. There's this concept that you call incremental calculation. People will occasionally refer to it as analyzing things or processing data in a streaming fashion. So the challenge that we have in Bro is that you're tapping 10 gig, you're tapping 40 gig, you have a lot of data. You cannot hold on to data. You have to clear your queue. You cannot build up a backlog, right? So when we get a little piece of a file, we got to do a little bit of the work. So when we implement all of these analyzers in Bro, and when we implement these, these heuristics in Bro, we're constantly implementing things in an incremental fashion. So when you think about calculating a SHA-1 or an MD5, if you look at that, how that actually works is that you can take a little bit of the file and do a little bit of the work. And then let's say this is 100. Let's say this is a 1 meg file. So the first 200K just flew by. So we have 1/5 of the SHA-1 calculated. The next 1/5 comes by, so we're at 2/5. We're 2/5 done with the SHA-1. I don't have to hold on to that other piece anymore. It's gone, right? It came in through Bro. I read it. It's gone. Incremental calculations is a very, very fundamental concept and very powerful. This is how Bro can scale to these tremendous heights, right? So the next piece of the file comes in. The next calculation is done. And so forth until the final piece of the file comes down, and then you have the finished calculation. So later when I'm demonstrating these analyzers, you'll notice that we're looking to build things in that have this kind of streaming API, this incremental API. So if this had been an executable downloaded, and we'll demonstrate the PE header in a second, right? So let's say that we'll look at P's in just a second, but if you're a malware person, you'll kind of know where we are here. The PE header would just be in this first 1/5 of the file. So as soon as we've seen that full PE header, I haven't seen the rest of the executable yet. Pew! This event can fire up in Bro, the PE header. So you can now hook that and reprogram Bro while this process is going on. You don't have to wait and do a full extraction and then pass it to this external tool and pull it in. I'm going to demonstrate doing that today, but I hope that you guys can understand the fundamental difference between the two, right? It's the ability to kind of finish all of your work as it comes in. So that's very important. I'll skip through my animation. I just like it. I thought it was nice.
Seemed like a good idea at the time.
Screw you, Bob. I'm just kidding. Just kidding. Okay, so what's out there now? So what have we added? So we've added MD5, SHA-1, and SHA-256. In a default install of Bro, MD5 and SHA-1 is enabled by default. Because it was free. When we were doing our performance testing on our largest networks, there was zero computational difference in calculating those. And that's because the circuitry for implementing MD5 and SHA-1 is built into the x86 architecture now. So it was just like a single CPU call to kind of do this. So we turned that on by default. So by default now you're hashing all the things, right? Hence the name for the talk. Now if you want to also generate the SHA-256, that will have a performance hit. In Bro, we divide these things in our script land between base and policy. So at our base, we're turning on MD5 and SHA-1 because we ship that as saying, everybody can run all this stuff in base. The SHA-256 is in policy because by policy, you need to make the decision to enable that. The second file analyzer that we have that's frequently used is extraction. So this is the ability just to extract files. Now, when you're doing that candidate selection process, you obviously need to turn it on at the beginning of seeing a file and not at the end, right? You can't go back in time here. I wish. There are data events, so if you want to pull data from scriptland into the Bro programming language, you can do that. There is an entropy analyzer now. It's available in our GitHub repo. So this is a concept that I'm not even clear what the implications are. I understand what entropy is and calculating it, but I've never thought about what it would mean to be able to know the entropy of everything on my network. And I haven't finished figuring that out. I'm running it at places. I'm still trying to determine, what I'm going to do with all that data. What patterns we can kind of tease out of it. And a PE header analyzer. The PE header analyzer is in Git. It does need a manual fix to get it to work. It's a limitation of our existing language we use to write file parsers, but we're working on getting that fixed and into Bro as quick as we can. So let's talk about the micro view of files. So this was when when we first started this conversation, we were out at the National Center for Atmospheric Research at a Bro workshop. There were like 40 of us, and we were all sitting on this little bus going to an offsite. And we're sitting there, and we are all like grouped around Seth, and we're like, Seth, we're in Bro 2.1. We're like, we want more file analyzers, right? We want the ability to extract files from everything. And he described this. He was like, no, that's not what you want. He's like, what you want is what you have now in Bro 2.2. You want this generic abstraction for files. And we're like, well, okay, I guess that is what we want. And it turns out it's pretty cool. But at the time, we had only thought about what does this mean about, we were thinking about files one at a time. So we're going to look at files now one at a time, and then we're going to talk about thinking about files all together in just a second. Not one more thing. So you now can start to ask yourself some of these really interesting questions. I know you can't read the slide, but the data doesn't mean anything to you anyway, because this is from one particular network, not your network. And what this is simply a count of files by MIME type for a given Bro sensor. And this is a very interesting analytic. So depending on where I'm tapping, I can start to infer and think about, well, 7% of the traffic on this link is XML traffic, and 9% is JPEGs. And there's this huge long tail of traffic, when you start to process these things. This is from this same sensor. Again, the numbers don't mean anything to you because your network's different. But you can see, you can get all the way down to the end here, and you can see that there were 3 Python files detected. There were 4 PGP keys. There was 5 PostScript files. All of this long tail of MIME types. And I think that as a community, we are still trying to understand what this means. It's going to take us a long time to really figure out, what can we do with this data over time? Is it worth monitoring the usage on your network sensors to see, what's just changing from the perspective of MIME types? And this is just parsing that line is there. It's just how I generated that parse. So Saturday morning at ShmooCon, I was a little hungover, and I was sitting in bed, and I had this curious idea to say, hey, I have this great files log, and you can see here, so this is GMT type, so you have to back out 5 hours. So this actually was 7 a.m., right? A little before that, I turned it on. I was like, what would happen if I took just the record of files and also added the source country code, destination country code, the source ASN, and the destination ASN to that files.log? So this is just abstracted away from IP addresses, and I just want to be able to ask myself and say, count the number of different executables and what countries they came from. So this was one of the first queries I ran here. I said, show me just a count of RFC 1918. That's this dash here, because there's no country code associated to it, and the destination host. And I was wondering, like, is this a valid technique? Does this mean anything? I don't really know. So I discovered very quickly that it does mean something. So running through the first 4 examples, I found 4 compromises, which was interesting. Now, I don't think that's always going to be the case, but this particular network is reasonably well locked down. It's actually a large number of stuff. I won't say what it is anymore, actually. So you have these hosts. And this is what I saw here. Let me walk you through the log here. I said, okay, so what in the heck is this file? So I'm looking at the HTTP log, the files.log there. I looked at files.log first, and it said, hey, this came from HTTP, here's the file. It said, okay, here was my source host, here was my destination, it was on port 80, transaction depth of 1. In an HTTP conversation, you can move lots of files around if you want. And it was a post request. So in HTTP parlance, that's the client, that's this guy, sending a file up to the server. Common method for web shells in C2 that I see. I monitor for high post counts in DMZs because it's a wonderful indicator of web shells. And this is actually, so I see the name, I'm like, okay, NS is usually for a name server, so it's a post request to a name server at dipmap.com, update ip.aspx. And if you check out the user agent here, you can see it's a Windows 7 box, right? So I was shocked by this because I looked this up and it turns out to be a dynamic DNS provider. And that was bizarre because I have a script that pulls in a list of every dynamic DNS provider that I know of, and it watches for DNS lookups, saves a table of all the IP addresses, and then fires a separate notice whenever I see any traffic to a host that was found over dynamic DNS. It's a great general heuristic for Bro. But this one wasn't on my list. And this new technique of just looking at files by country code or files by ASN let this particular incident bubble to the top. And so I really like this one because I thought I had this specific concern really well locked down, and this found something that right away got through my sensors. Now, I don't think that on a global scale that just nailing things by country code is 100% accurate, and or even ASN, because I do see a lot of threat actors that will just compromise an intermediate host or a number of intermediate hosts and then attack you through there. So let's really get our hands on this. Let's look at a couple quick demos, and then we'll come back, and then we should have time to think about files in a whole. So here is an example that Rob mentioned, actually. So this is a host that is, I'm looking at my HTTP log here. That is, I basically started my files.log and I said, okay, show me all the executables downloaded. And then looking at the HTTP log, I could see that all the user agents were Java. So I thought, hey, that would be great. Let's write a Bro script that detects whenever you download an executable or a PDF, or in this example, I lock it to EXEs, but it'd probably be useful to know everything that you download with Java. So let's just take a look at how easy that is to do with this new files framework. So I have a PCAP here that is from Contagio Blogspot, and let's just kind of walk through some of the basics here, right? This is the connection log, and if you're not Unixy, this is highly structured data separated by tabs, so this is sexy, right? So you've got your timestamp, you have the unique ID here, you have your originator and responder tuples. We don't say client, server, and Bro. It doesn't make a lot of sense. Ask me later if you want to hear a little story. Dynamically detected protocol, the time and length of the session, and so forth. So you can, all these logs are connected. So we're at the connection log, and then we have an HTTP log, and then you have this files log that sort of meta describes this transaction here. So let's look at the HTTP log. So this particular bot, if you're not familiar with it, and we don't have time to go through the full incident response process here, is click fraud. Okay, so you can see it just does a metric crap ton of host and refers. A general script to detect this may be to monitor for actual websites your clients visit by hooking the host and then comparing that to refers. That would be a good Bro script. It would be very short, and I think that I will write it when I have some free time. So looking at the files.log though, I was able to quickly ask myself, well, I don't like to do signature stuff. I like to do what's the greater heuristic. So looking at these, I started my process and I was like, okay, just show me all the DOS execs downloaded. Right? And a lot of people will point Bro at Splunk. I don't like to demo any of that because I like to demo just raw Bro. This is Bro. Right? So you can see here's these DOS execs. And if we check these out in the HTTP log, you'll see that the sample of the screenshot I just showed you there. Right? And here are these three files. And this is what we're going to trigger on here with this files framework, right? I see the user agent is Java 1.6026. Somebody does not give a crap about security at all. All right? So the full program to do this, right? Program is this. We say Boom, whenever there's a new file, I don't care what protocol it came on, boom, this just fires up into script land, okay? I hook it and I say, right, is there a user agent? See this little question mark? If you're a programmer, that means like, does this exist? So if it exists, I'm also asking, hey, this was from HTTP, and there's a user agent set, and in the RSP MIME types, right? In the MIME types from the responder, there is Java, that's a regular expression, in the user agent. Okay, so if all that happens, then what we want to do is just print out a little line of screen here, and it prints a bunch of gobbledygook. I want to move on to the next example because I generally like to talk a lot about Bro. All right, so the next example, let's go back to the presentation. Okay, oh yeah, hey, look at that. I had some animation there. All right, so who is any malware analyst here? All right, one or two. Okay, so you guys know what the PE header, you guys could probably explain a lot about this to me. So generally you think about your file, it comes down as like, think about it like a book. You know, there's like a table of contents, there's an introduction, there are different chapters in a book. It's an interesting way to think about a file. So what we're doing with our PE header analyzer is that we're gonna parse out some of these tables that you guys are more interested in seeing here. Specifically, some of the information that we're pulling out automatically for you would be things like, what are you importing? What are the different section names? A common technique may be to look for anything that's downloaded that references is debug present, right? That would be an interesting thing to look for. Doing that on real networks, I found Perl.exe moving around. It was not malicious, it was just moving around. I don't know why you're copying it down, but they were. So we could go ahead and replay that, but I want to move on because I'd rather show more demos than not. So file hashes. We talked about one earlier where we hit on known bad things. And the files, revolving around this files framework, because we're now hashing everything in Bro, you have to think very carefully about what you want to do a lookup for. Internally, you can pull millions of these file hashes into Bro. That's what it's designed for. And we'll look for them in all the places, right? If you give me a domain name, I look not just in DNS request, I look in HTTP host headers. Maybe when we'll look at that PE header analyzer and look for any domain names in there, like for signing keys. That would be a good place to look. We're not doing that. But we look in like 70 different places for all these like many-to-many matrix things, like back and forth, waving my arms like a madman, right? So let's look at another example, though, where we actually pivot out to an external data source. All right, so Blackhole, everybody's heard of that. So in this example, we have a host reaching out and downloading a known bad thing. Let's just call it that. And we're passive, so this could be a device under my control, this could be a vendor on my network, this could be whatever. And the money shot would be to go right to the notice.log, where we simply say, you know, I could walk, you know, the files.log still looks the same, but the policy that's running just says for every executable PDF, zip file, or jar file, send the MD5 to this DNS registry that Team Comrie provides. And then this is the kind of data that's coming back. Team Comrie will tell you when it was seen, when it was last seen, and so forth. Important consideration. You are technically leaking data when you do this, but you're only leaking the file hashes. So if you're not okay with that, turn it off. Pardon me? Question?
It's just metadata, right? That's not collection.
Oh, it's just metadata. That's not collection. That was a comment from the peanut gallery. Okay, so let's go on to a fourth demo here. And I think oh yeah, GitHub hashes. So I had this really interesting idea with a friend of mine, a fellow NoVA hacker, Mr. Wick over here, who is well known for hashing all the things, or for downloading all the stuff, right? And I was really disappointed. I was doing some tests. The National Software Reference Library has like 69 million file hashes in it. And I was like, certainly it's got web resources. And I was like, I bet I could like, you know, find out what kits and libraries people are running on their servers. And I got nothing. I got no hits. And I started looking through the list and I was like, there's no WordPress in there. There's nothing. If there's somebody from, you know, MITRE, that whole group, you know, you guys got to go, you know, talk to the GitHub guys and get hashes for everything. Because the data is really interesting. And I think that there's a separate talk just on this one topic about finding out where the things you're running on your network come from and being able to look for and discover vulnerabilities. So Wick and I had a quick phone call and maybe a few chats, and he is running a project called Git Digger. If you haven't seen his talk, you should check it out. It's very interesting. And so he quickly added the ability to calculate a variety of file hashes for me. We also have fuzzy hashing. I didn't put that on my list, but SSDeep is on there too. And this was the kind of data that came out. I was actually really pleased with this. So let me walk you through what we haven't seen before. So in our Intel framework, you essentially take all the hashes, all the domains, whatever the Intel is that you want to find, and you shove it into Bro. And it looks like this. You take a file and you, what do you call it, right? And you say, hey, Bro, load that, right? It's that easy. And then you say, well, here, what do you put in your file? So this is a file that has all the file hashes, the MD5s, of every file from every version of WordPress that is in their GitHub. We just did a recurse through the whole thing. So in total, it's a couple million file. I don't know, a couple million. It's a pretty big list, whatever it is. And what I basically did was I basically tagged it out by version of the Git repo that it came from. So the alert that I'm going to fire is when I see a file hash that I've seen before, I want to take that and tell you that this file came from one of these 5 repos. Not only these 5 repos, but this particular branch in the repo. I think this is interesting. And I'll show you an example, or I'll tell you why. All right, so here is what's actually firing. That was ugly. All right, I hope you guys don't mind the command line. I personally adore it, so that's why I like to spend time here. So this is us saying that here are the files that we were downloading, and here's where it was firing. So doing these recurses through these websites here, the geekstuff.com and Entice Creative, we start to see that, you know, this iconsmile.gif is in WordPress master, blah, 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 blah. So future work in this area includes, I think, tracking, you know, the collection of hits over time, so you could start to narrow it down. As you get more and more hits out of a framework, you could start to narrow it down and say, and you're running WordPress 3.2 downloaded from the Git repo on this day. That is not work that I finished working on, but it's something that I'm actively pursuing. So that's just sort of an insight. I have some other websites that I was running against. I just was doing some massive scanning. And you can discover lots of interesting plugins. It wasn't, you know, when you visit some other sites, you know, it's not always, WordPress isn't always installed to /wp-admin or, you know, whatever the default install is. So I was able to figure out what, you know, specific plugins that these websites were running, which from an offensive and defensive perspective has some very interesting use cases. The key is, of course, having the data. And thank you again, Wick. That was a nice collaboration there. So the 5th example is not something that you're going to want to do full time. Now we're going to take a file, we're going to pull it off the wire, we're going to then spin up a new process over here and exec out and put that file in that process, right? Now I'm going to run Exif tool. And the reason why I have this example is I like to point out that it would be pretty easy, trivial in fact. Oh, hey, look, I named 2 things 5. To do all right, so in this Bro script, what I'm doing is I'm telling Bro to take any JPEG or executable and send it to Exif tool, specifically because I want to extract the GeoIP information. So the capability demonstrated here is grabbing something off the wire, pulling the geotags out, and then maybe you could program and say, okay, well, if this picture was taken in this little polygon here, send me an email. So if there's anybody in theater or anything like that, this is a valid technology. Now, as I mentioned, spinning out to Exif tool is not the Bro way to do it. This is not a streaming integration. But this code is on my GitHub if you want to use this as a starting point for any other integrations that you would like to work on yourself. That's why I did this specific example. The better way to do this would be to put a JPEG analyzer in Bro. And if there's anyone out there that's interested in sponsoring that, I can set you up with the right people to get that done. Just a subtle little point there. So thinking now about files as a collective, like let's take a step back and start running some interesting analytics and saying, what does it mean to now have this new capability? To think about having the hash for all the files, all the time, on all the protocols for all the clients. The data is very interesting. This is the area that I don't think that we're even close to fully exploring yet. So again, the numbers don't mean anything to you. This was simply a count from a bro sensor, the count of the number of times I saw this file, and this is its MIME type, and this is its size. And I did some sample rundowns on these. I think we'll move into one in a second. But it's also interesting to look at what are the least popular files moving around your network, or what are the distinct files moving around your network. At some sites, we have very large deployments, 600 sensors, very large deployments of Bro. So it's an interesting question to ask and say, what files have I only seen in one place? What is going on in this that makes this different from my other clients? Typically, when you're deploying resources and clients, you're deploying things in mass, right? You have 50 accountants, you have 500 accountants, you have 10,000 bank tellers, right? Shouldn't all of their activity and the applications they're using look the same? There's a lot of work here that is probably like a whole, somebody pick this up and run with it. We're very bandwidth constrained. We've got a lot of great ideas for this technology, but let's take one of these and run through it. I'll show you what I found. So this is me on my beloved command line asking, say, okay, what is show me one example of this file at the top of that list there, the most popular file on that previous network. Again, it doesn't really matter what it is. And I started running through and actually looking at the files. I extracted one copy of each file, and this was the contents, and I had no idea what it was. And it turns out that this is a very interesting environmental control system that I was able now to identify on my network. And this led me right into a very interesting way to think about interacting with networks. I could suddenly now identify a single characteristic or a distinct characteristic of a file or of something downstream, write a policy, and reprogram Bro dynamically to enforce some kind of a policy. And that is exactly what we're going to do after the slide, because it's out of order. So asking these questions, is this interesting? I think sometimes it is and sometimes it isn't. This was not a slide that I made. This was actually a default slide that I downloaded, and I kind of liked it because it has a bunch of nonsense on it. And when you're evaluating things by country code, that is a lot of times what the results are, because the network of networks that is the internet is quite commonly abused, and serious threat actors are well aware of the ability to look things up by country code. But there is still a lot of low-hanging fruit. So let's get into this last example, and what we're going to do is, this is a large network of these things, right? Of the Internet of Things. So this is everywhere. This is not just hospitals. This is not just the energy market. This is every industry is chock full of these things. If you're in commodities, maybe it's the scale heads. If you're in medical, it's MRI. It's lighting. It's transportation. It's your building. So this growth of embedded devices is going to screw us all for a couple of reasons. The primary reason is that we're on the wrong side of math. So things that we cannot manage, there's no SCCM for this, right? We can't update these things. If you're running a refinery or whatever the case would be, you're not going to get to update these things. The trend is against us here. And the ratio of devices to us is increasing dramatically. So how can we use this files framework to really get a hold of this? So as an example, I took a Sony PTZ RZN30N, and I basically looked at it because it's a Linux box, and I like hacking things. And I downloaded the firmware update process, and I replayed it through Bro. That's like my secret to finding 0 days. Download the firmware updater and see what it does, because that's generally what you want to do, right? I want to install my own software on you. So here's how it works. It authenticates to device. So in my case, I scanned for devices that were default passwords. And you enable an FTP server with that secret FTP command right there, that CGI command. And then you can upload whatever you want to that directory, and then you simply call another hidden CGI command, and it will install whatever you've just uploaded. So hanging out with Rob and the other NoVA hackers, I am a bastard in training. And so this being a Sony web camera, I installed a malicious Java applet that, because when you visit the camera normally, it prompts you to install the creds. I have like 1 minute left and I should finish, so I'm close. So this whole idea, though, that we're going to demonstrate in this final Bro script is using this files framework to sort of revolve around what is different about this particular device. So what we're going to do is we're going to, in this previous example, this is what it looked like when I hacked it, right? Green is good HTTP traffic. The other stuff is not good. So just by understanding what one device is supposed to look like, what I do then is I use this files framework to say, hey, how can I identify those cameras? I don't know where they are. The documentation's wrong, right? I can't scan this because this is an energy refinery place, and there's SCADA controllers mixed in. So I'm limited on my tool set. I have to be passive. So the first thing we're going to do is we're going to look for a file. Let's actually look at the code. Screw the last slide. All right, so the code is simple. We simply say, hey, look, there's a new file. Is this the Sony logo, right? That's what that's a hash of. Or are you serving the other Sony logo because there's a new version of the firmware? And then we simply say, okay, if you are, add that particular device to a watch list. And then whenever I see a device speaking that is on the watch list, I then say, are you speaking approved communications? Is your producer-consumer ratio match what I expect you to do? Now, take my specific examples and just generalize them. If this were a bank teller, say, are you accessing only these 5 websites? Are you accessing only these files? Are you having something distinct, something out of order here? And if you are, go ahead and start extracting all the files, right? That's all I do. So I'm now dynamically, this bro script in less than 50 lines, I tell bro to find all the Sony cameras, enforce a policy on them, and when I see it violated, go ahead and start just logging. Take a file extraction and replace it with send an email or do something else. And it works surprisingly well. I use this to identify a network with many hundreds of these cameras. And it was actually very informative of me to correct network documentation, which I always ask for to prove a point, that it's wrong. I like to work with the ground truth of things, which is bro. And I think this is essentially the end. I could show you the logs, but you guys have, I think, seen enough of that. I don't know if I have that much time left. Maybe one or two questions about what we're doing?
We're done with time. Any questions?
We're done with time. Okay, well, I sincerely appreciate NoVA Hackers. Thank you guys very much.
This has been a presentation of NoVA Hackers at ShmooCon Epilogue 2014, hosted by Mach37, brought to you by ComputeCycle. Video recording and streaming services provided by Cranial Thunder Productions.